Hey guys, my name is Ethan, this is Carberra, and welcome to Suze, where I teach you how to analyze and visualize data in Python. In the last video we did linear regression, and in this video we're doing an extension of that in polynomial regression. So it's the same sort of thing, except it kind of gives us more of a trend of our data, especially if you're doing stuff with time series on the x-axis, where you want to see the trend of data over time, because it actually curves the line of best fit per se to actually fit these trends. So it's really useful for that sort of thing. Of course, if you found the video helpful at any point, then consider liking to let me know and subscribe so you don't miss out on future videos in the series. But yeah, with that out of the way, let's get into it. This video is actually going to seem quite similar to the last one. There isn't really that many changes that we need to make to get polynomial regression going. But I am using a different data set because I felt this one worked better. This was one it's the same as the other one, but it's just all the data since I've been partnered. So I think it's the 12th of October 2020 to the end of March 2021, I believe. I could be slightly wrong, but do let me know if I am. And there is one extra import. So we have from sklearn.preprocessing import polynomial features. And these polynomial features are what we're actually going to be using to do our regression. But you can see here that we still have our linear regression object. That's because we're going to be using that to actually regress still, but instead of regressing on a straight line, we are regressing, using curves. So I'm going to do the same thing as before and kind of create the function here and then just kind of pass it out. We do need an extra degree variable, but I will explain that as we go. Let's just run that to actually load all the data, make sure it's loaded correctly. Yep, it is. Fan-dabby-dozy. And we can come down here and do data equals df views CPM. I'm just using the CPM values this time, hence why I'm using the while partnered one, because the other one includes data where I wasn't actually earning any money. And then convert it to a 2D NumPy array using dot values. And then we can do pred again equals polynomial regression data equals 3. Data and then 3. I think I'm going to explain what the degree does specifically when I can actually show it off, but it's essentially how much or how severe the polynomial regression is. So you remember in the KDE video where we could change, I forget exactly which variable it was, but we could lessen the smoothness of it, and it started turning a bit more juttery. But we can do that with polynomial regression as well. And I'm going to be showing that off, changing the degree values so we can see what it actually does. So these first two lines are actually pretty much the same. So we're going to get our x value and do a reshape, -1, 1, and then a y equals data. Like that. The only reason I'm typing all this out again is because I feel as though there will probably be some people just looking for polynomial regression stuff and have joined this straight. So I'm just kind of going through all this again for the people that didn't watch episode number 14. If you do want to watch that, there is a card in the top corner. So this is where the changes start coming in, because we actually need to create our polynomial features. So we have features equals polynomial features degree equals degree. And this will kind of create really everything we need. So we don't need to do any of this manually. So we can have xpoly features.fit transform x. And then beyond that, it's the same as before. So we have our linear regression. And then we have our reg.fit. And then we put on xpoly and then y. And then return reg.predict xpoly. Whoopsie daisies. If we run that to update the function, and then come down here, and it's pretty much the same. I'm just going to copy paste it from my notes. But yeah, you create a figure, you do the scatter plot, you do this line plot, so you have the x equals to the views and y equals our pred value here, and then we set the line width to be 3 so we can see the line better. And if we run Control Enter on this, we will get a curve that looks something like this. So as you can see, the curve kind of curves up and then it goes down near the end. For some reason in February, was it February? I think it was February and March, and I think a bit of April as well. The channel just took a weird downturn. Don't necessarily know why that was. I think it had something to do with the nerfing of the community tab. But that's not really important. The channel is kind of picking up again now. But yeah, it just shows off the curve really well, is what I'm trying to say. So you have this, it's probably not immediately obvious looking at all these dots where the correlation is and kind of what the trend is. But this polynomial regression allows us to see, okay, it was going up here, and then kind of it tails off near the end. Actually, I just realised it's lower. It's not by day; it's by views. So apparently, about 1,450 a day is the ideal. I think it's been pushed up by these 2 days here. I don't quite know. I think these might have been like transactions on live streams, because I don't stream on YouTube anymore, and that might be throwing it off a bit. But, you know, the curve is still very prominent. And we can actually change the degree here. Yeah, it's definitely something to do with when I load into the plots, the keyboard just turns off. I don't know why that is. That is very strange. But if we reload the thing, it will work again. So, whatever. Change that to 5. We've got to rerun the entire thing. And we get a more detailed graph. So we have this down and it goes up again, and it goes down and it goes up again. So, yeah, the more degrees of polynomial regression that you have, the more detailed or the less smooth the line is. And we can keep going on this. I've got to close and reload it again. Hopefully by the time you're watching this video, this problem would have been fixed, because it's very annoying. But we can go up to 10. We can run the whole thing again. And okay, so this is the other thing I wanted to talk about. There is a point where the polynomial regression just doesn't get any less smooth or any more specific. So it kind of depends on your implementation. If you do a fully manual implementation, which I will actually show you briefly before I go, because it's part of a uni assignment, you can, it starts going wrong at higher values, but it will actually get more kind of crazy to look at. But using, you know, the sklearn, I think NumPy has one as well, but NumPy's one is really quite broken, I think. But sklearn's one, which is what we're using here, works a lot better. But it still has this thing of, you know, if a degree is too high, then it doesn't go any further. I think it detects an overfitting automatically and prevents that from happening. But yeah, essentially, in short, polynomial regression is linear regression of the curve. It takes a degree and it creates these features. I'm going to load up a different file now briefly and show you kind of more in the back end or at a lower level what's actually going on here. So this is the function that was in my assignment. As you can see, it is quite something to look at. It's not the easiest thing in the world to understand, especially considering that I did make some changes to kind of intentionally flex on my lecturers a bit by showing all sorts of different like syntactic sugar and stuff. In the long run, maybe not the best idea, but I can still explain what's going on. So essentially what we're doing here is, well, it's probably best I explain what polynomial regression is first. So polynomial regression, or at least the features of polynomial regression, because this actually gets the features, is taking the data and taking it to the power of every number, including 0, up to the degree. So this x equals mp dot 1's x dot shape is taking our x data, all of it, to the power of 0, because anything to the power of 0 is 1. So it's just easier to create an array of 1s here straight up. And for each one, it's doing that it's taking it to the power of every number up to and including the degree. So it starts by, you know, taking it to the power 1, which is the same as it always is, and then it squares all the values, then it cubes them, then it takes them to the power of 4, then to the power of 5, then to the power of 6, then to the power of how many degrees you actually go by. And it stores that all in one huge list. And this last line, I couldn't tell you the back-end mathematics as to what's going on here, because, to be honest, we took this, this was kind of provided to us in the assignment. I just changed it up a bit. But essentially what this does is it returns the new y values. So it takes all of this that we created, all of our polynomial features, and it just kind of crushes them together into a list of coordinates that we can actually use. So I could probably show you that it's the same. Let's just hope that this actually works, because I really don't know. Actually, I'll show you what happens if you print the pred first. So you get all these values, and if we look up here, you can see that a lot of them. Well, actually, what degree are we even using? We're using 3. Okay, let's change the degree up here to 3 again. And then I can probably just show you that the values are the same. Just load that again. So we have all these different ones here. So you can see, it matches up more or less the same. I don't know if it's exactly the same, to be honest. Okay, maybe I will graph it, because those plots don't look entirely identical. I could be wrong, but I guess there's only one way to find out. So will that just work out the box? It does. Okay, it is the same. There we go. So I think the plots themselves are just a bit scattered. Let's actually see if we can get a scatter plot on this. Oh, no, it is a clean line. Okay, I don't necessarily know what was going on with like the 8.2 and then the 8, where it looked as though it shouldn't be that. But yeah, as it works the same. So doing it like this and doing it like this are the same. It's the same stuff in the back end, just one of them is a bit easier to understand, and the other just takes NumPy as an import. So if that's a concern to you, then feel free to just use this. I hope I'm not violating the copyright of the university by using that, but I guess we'll find out. If I get a lawsuit and the channel goes off air, then you know what happened. But yeah, that's all I wanted to talk about with polynomial regression. It's probably one of the trickier things to kind of understand what's going on in data analysis. But once you kind of see what's happening, and hopefully the explanation I gave made sense, then it sort of makes sense. At the very least. But yeah, if you do have any questions about what you've seen, then feel free to leave a comment down below, or you can join the Discord server using the link in the description. But yeah, with that, I'd like to thank my incredible patrons for being superb human beings, and I will see you next time for the final episode in the main series, at least. Obviously, the requests can still come in, where we are talking about clustering, specifically k-means clustering. So I'll see you for that.